Okay, so last section we're going to look at in chapter 1 is 1.6. First part of 1.6 talks about different things we can do to functions. We'll talk about some simple operations, and then we'll get into one called composition. And then the last thing we're going to look at is a chart that kind of shows us all the transformations that we've learned. It just organizes them all into one nice chart so we can see, in general, how does it look if you shift a function up. Okay? Not just a parabola, but anything. Okay? They all work the same way. And so we'll look at that at the very end. Right, so when we perform an operation on a function, the idea is you're taking two functions that you already have and you're combining them together to make a new one. So they'll give you one function, they'll give you another one, and they'll just ask you to put them together. And there's different ways you can do that. You can take two functions and add them, subtract them, multiply, or divide. Okay, and I'll show you an example. Okay, I'll give you two functions, and I'm going to have you combine them together. Now, sometimes when you try to combine them, there's not really much you can combine because there's no like terms. If there's no like terms, there's not really any simplifying you need to do. Like in this one. So one function is x squared. The other function is the square root of x plus 1. And I want to combine them together to create a new function. The way I'm going to combine them is just to add them together. So when I add them, that's all I can really do. There's no like terms. Okay, but this is a brand new function. If you were to graph what's in that red box, it would look a little different than either of the original functions because it's a combination of the two of them together. Any question on that idea? Just creating a new function from two that you already had. Now, if you're wondering, like, what would be an example where you could combine them? If you had, like, f of x was 2x squared, and g of x was 5x squared, well, and I said to add them, you could write 7x squared. Okay, that's an example where you've got like terms, you can simplify. Here, you can't. Okay, let's try this one. F of x divided by g of x. Okay, so Shai, if I was going to write that out, f of x goes on top. And which function is f of x?
F of x is x squared.
X squared. We got that. And Isabel, g of x goes on the bottom. And what function is g of x?
The square root of x.
The square root of x plus 1. And there's not really a lot you could do. I guess the only thing you could do with this one is we don't like to leave a square root in the bottom. So you could fix this one by multiplying the top and the bottom by the square root. It's not going to get rid of the square root. It's just going to move it from the bottom to the top. Okay. So you'd end up with x squared times the square root of x plus 1. And then whenever you multiply two square roots together that are the same, it basically cancels this part out, and you're just left with what's underneath, x plus 1. Okay, so we get square roots out of the denominator all the time. It's usually numbers. In this case, there was also a letter. Any questions on what we did there? So the important thing we got to remember is this function had a domain and range to start with. This function had a domain and range to start with. Well, when you combine them together, you've now changed that. This new thing that you've created, it has its own domain and range. And that's what we want to try to figure out. Okay? And it comes partially from the original, but we're going to look at that a little closer. Okay. There's more examples on page 58 of combining functions if you need to see more. So, how would we figure out the domain? of that or that. How would we figure out the domain of the new function we created from the originals? Well, the domain is basically all x values that work in both original functions. Not just one, they have to work in both. All right, so if I look at f of x, and I ask myself, okay, what's the domain of that? I'm squaring a number. That's the only operation here. Is there any number that you are not allowed to raise to the second power? What do you think, Connor?
No.
No, you can square anything you want. The only two things you have to be careful about is if you have a square root, because you're not allowed to take the square root of what kind of number?
Negative.
Negative. So if you have a square root, you got to be careful. And when you have a fraction, you're not allowed to divide by what number?
0.
0. Those are the only two things you have to be careful with. So with f of x, I'm fine. But g of x, I'd have to be careful. I couldn't let x be negative 10. Because if I plug in negative 10 plus 1, that's negative 9. That's no good. So what could I let x be? Any number from what and on? Negative 10 doesn't work. Negative 5 doesn't work. Yeah.
Negative 1.
Yeah. And
On.
on. Yeah, negative 1 and up. So anything negative 1 or up. And if you're like, well, can you take the square root of 0? Sure. That's not a problem at all. 0 square root is 0. It's just if you try to do negatives, then we get a problem. Okay? So the domain, when we put these together, we have to think about x's that work in both. So if I said, what about negative 2? Well, negative 2 works there because you can square it, but negative 2 doesn't work there. All right, so you have to think about values that work in both. Kind of think of it as like you're trying to make everybody happy. Right? You got to find something that would make this happy and g of x happy, right? Not just one of them. And the other thing we got to be careful, and I already mentioned this, is if you combine the functions together, like we did here, you just created a fraction. Neither of the original problems had fractions. So if you created a fraction, make sure that you never plug in a number that would cause you to divide by 0, like negative 1 in this case. Okay, so those are the two things you got to be careful about. Make sure you never divide by 0. Make sure you're always taking the square root of a positive number, not a negative. Okay, so we'll go through, we'll practice just creating some new functions and then finding the domain. And we'll do some range as well. Range, you usually want to use your calculator to kind of help you. Domain, you should be able to get just using those two facts. Don't divide by 0. No square roots of negative. Okay, so first example, you're giving us two functions. F is the square root of x plus 3. G is the square root of x minus 2. So let's start by finding the domain of each one individually. All right, so Isaac, what do I have to be careful about with square roots? I can't do what? Yeah, we can't take the square root of a negative number unless we do imaginary. We're not doing that. So in order to make sure that that doesn't happen, Nick, what kind of numbers would I have to pick for x? I agree, positive numbers would work, but I think negative 1 would also work, right? Negative 1 plus 3 is okay. So there are some negatives we can use here for x.
Any number except -3.
Any number except -3. So -10.
Any number. Any number above -2 or above.
How about, you're gonna hate me. How about -2.5? That's not above it, but -2.5 does work. It's below it.
That would work well.
Anyone? Yeah.
X is bigger than -3.
Or equal. It can equal because you can take the square root of 0. So you can pick any number from -3, including up to infinity. I see what you would get in there. How about x, the square root of x minus 2? What kind of numbers would we have to pick for that one? About Emily?
2 or higher.
Yeah, anything 2 or higher. If you go lower than 2, you're going to have a problem. Like 1 minus 2, that's a negative number. All right, so now we know the domain of each function individually. That's going to help us when we combine them. Now, you can't combine square roots unless the thing under it is the same. So there's nothing to combine when you write this out. It's literally just going to be this. Now, if they were both x plus 3, like square root x plus 3 plus square root x plus 3, those can be combined together. That's 2 square roots of x plus 3. Okay? Because you're adding, you'd have 2 of them. But these aren't like terms. So now the domain is all x values that would work here and here. So what kind of numbers could you pick that work in both? Kind of want to think of it as like, which domain here is more restrictive? I know they both go to infinity, but if you think of it that way, that kind of helps. Which one doesn't include as much? Yep.
Any number greater than or equal to 2.
Any number greater than or equal to 2. And if you're thinking, well, I could use 0 in the first one, sure. 0 plus 3 is okay. But you can't use 0 in the second one. Okay. It's got to work in both. So that's the domain. Any question on that? Okay, let's try this one. F of x divided by g of x. Okay, so Emily, could you tell me how I would write f of x divided by g of x?
But x plus 3, well, square root of x plus 3 is over square root of x plus 2.
Square root of what?
X minus 2.
X minus 2. Now, I'm not super worried about the square root in the bottom. That's fine. I just want to see if we can figure out the domain. So the domain here is all x's that work in both of these. Well, we already know that from the last problem. But this one is a little different, a very small difference in the domain. Yeah?
It's going to be 3 to infinity because you can't have the tail.
What about 2.5?
Okay, so not less greater than or equal to, just greater than.
Just greater than 2. So the domain here is 2, not including it, to infinity. So we know that we can't use 2 because look what happens. If you plug in 2, 2 minus 2 is 0. That's fine. Square root of 0 is 0. That's fine. But then the problem is you have to divide by 0. That's not fine. All right? So we can't divide by 0. So any question why we don't include 2 here and we did up above? Okay. Let's see. All right, let's try this one. So this one says to graph and then find the domain and the range. Okay, I want to show you this because I'm not sure if I've shown you where absolute value is in the calculator yet.
You did.
I did? Okay. Well, then I'll ask somebody to tell me where it is. So it's f of x divided by x. Okay, so to graph it, how do I get to absolute value? Yep.
You would do the math,
Mm-hmm.
go to number, and it's number 1.
Yep, first option. So absolute value of x divided by x. And then hit zoom 6. And you get kind of an interesting graph. If you got something that looks like that, then you did it correct. So when we look at it, the domain here is pretty much anything you want except one number. What number could you not fill in for x? 0. That's the only one. There's no square roots, so you don't have to worry about that. You just can't divide by 0. So domain, you could say negative infinity up to not including 0, or that's a u. The u is actually pronounced union, but you say or. Pick a number from 0 to infinity, but you're not including 0 either time. Now, the range. What are the y values that we get here? There's not really a lot of them. Yep.
1 and negative 1.
1 and negative 1. So this is actually an example where we can list every single number that's in the range because there's only 2. 1 and negative 1. And the reason, well, pick a number for x and plug it into that. If you try like 5, the absolute value of 5 is 5. 5 divided by 5, 1. If you plug in 10, you're going to get 10 divided by 10. It's 1. If you do a negative 5, absolute value of negative 5 is positive 5 divided by negative 5. Positive 5 divided by negative 5 is negative 1. So if you plug in any positive number, you get 1. Any negative number, negative 1. That's it for that one. Any questions on the domain or range there? Okay, so the next thing we're going to look at is a different way to take two functions and put them together. Okay, so not adding them or dividing them or subtracting them, but composing them, okay, or what's called composition. So I'm not going to really write out a definition of it. I'm just going to show you an example. But the idea of composition is you take one function and plug it into another. That's composition. It's not like you're plugging in a single number. You're taking an entire function and plugging it into another function. So let's try it with these two. So I've got function g, function f. G is the square root of x. F is x squared plus 3. So first thing I'm going to show you is the how you write it. Okay, what does the notation look like? It looks like this. G, and anytime you see a parenthesis, you pronounce it of. So this is g of f of x. So let's take a step back and pretend like it was a number. If I said to find g of 4, what would you do with the 4?
Put it in place of the x.
You'd put whatever's here in place of the x. So if I said to find g of 9, you would take the 9 and put it in place of the x. Well, I'm asking you to find g of this. So take whatever is here, and we're going to put it in place of the x. So let's write out what we have. G of Now go up and look at what f of x is. X squared plus 3. So if this was a number like 4, you'd plug 4 in for x. If it was a 9, you plug 9 in for x. If it's an x squared plus 3, you're going to plug in an x squared plus 3 for x. So you're just plugging something in for x. Okay, so let's do it. So we've got the square root of, and now plug in what they're telling me. X squared plus 3. And that's it. That's a composition. You plugged one function into another. Let's try it the other way. Do you think I'm going to get the same answer when I plugged f into g? Now I'm going to plug g into f. Do you think I'll get the same thing?
No.
No, I'm not going to get the same thing. So now I'm doing f of, now look up what g of x is. Square root of x. Okay, so you're going to look at function f, and everywhere you have a variable, replace it with that. So I'm going to go up, I'm going to look at function f. Everywhere that I have a variable, I'm going to plug in what they're telling me. Square root of x. So I get the square root of x squared plus 3. What's going to happen there? Yeah?
The square root and the square are going to cancel each other out.
Yes. The square root and the square cancel each other out. And your answer is just x plus 3. Now, you can probably guess what we're going to talk about next. What do you think we're going to describe about this next? Can you guess the hint? Same thing we've been describing with all the functions we've looked at so far. Yeah.
Domain and range.
Domain and range. I'm going to describe the domain and range. And you might think, well, isn't the domain anything? Like you can take anything you want and add 3 to it, right?
No, because even if you square it.
Yeah, the whole square root thing, that's kind of a problem. Yes, you did cancel it out, but it was there originally. And that means because it was there, you can't forget about it. All right? So we'll talk about how do you figure that out? How do you find the domain? How do you find the range? I stick with the notation you're seeing right here, but if you see it written in words, sometime in the book they write it this way, the composition of f by g. I don't like writing it out in words like that because when you write it that way, it's actually like you have to switch the letters to use my notation. So I always just stick with this notation. I think it makes it simpler to understand. But what I have up above is technically the same thing. You can see this too sometimes. If you see like a G, a small circle, and an F, it just means G of F. So whenever I see what that little circle, I always change it to what's in the box. Makes more sense to me. Okay, so just different notation. All right, so to find the domain of a composition, how do you do it? There's 2 steps. The first step is to look at your inside function. Okay, so what do I mean by inside? This was our first example. F of x is on the inside. In our second example, g of x was on the inside. So look at the inside function and ask yourself, is there any problems with the inside function? Are there any values there that I have to make sure I rule out? And there's 2 things you want to look for. If the inside function is a square root, you're going to be ruling out some numbers. If the inside function is a fraction with a variable in the bottom, you're going to have to rule out some numbers. Right? So we do that, we just kind of keep that in our mind. We're like, okay, we can't use these values so far. Then we check the final answer. And we say, okay, let's look at the final answer. Are there any other values looking at that we can't use? And in this case, I would say no. Adding 3 to a number, that doesn't affect anything. You can always add 3 to a number. So in this problem, the second one we did, if there is any restriction on the domain, it would come when we do step 1. You're not going to get anything in step 2 in this particular problem. Okay, so check the inside function and then check the final answer. So we'll try that. We're going to do a different example, but same thing. Okay. Does everyone that wants to copy those 2 steps have the 2 steps? Exclude. So I'm going to check the inside function for anything I can't use. I'll check the outside or the final answer for anything I can't use. And then I'll write down whatever's left. All the ones that still work. Okay, so this one is actually just practicing plugging in a number. It's a little easier than what we did. But we can try it. So, what are you doing with the 9? Let's see.
Yeah.
What are you doing with the 9 here? What function are you plugging it into?
Plugging it into G of F.
Yeah, you're plugging it into function g of x. So let's do that. If you plug 9 into g, you get the square root of 9. And now we need to simplify that. What's the square root of 9? 3. So now, what number are we going to plug into function f? 3. So it's kind of like a chain. You do the inner one, get the answer, and then plug it into the next one that's on the outside. So now plug 3 into f. 3 plus 1 gives me 4. So that's just evaluating something with a number. We're not really going to spend a lot of time on those kind. We're going to do more with these kind. All right. Reading that, can somebody tell me what function is getting plugged into what? Are you plugging f into g or g into f? Yep.
G into F.
Plug g into f. Plug g into f. So, square root of x plus 1. That's it. Okay, let's try it the other way. So now we did g into f, f into g. So f into g. So the square root of x plus 1. Now, when I pronounce these answers, they sound the same, but they're not the same. If you think about them as a transformation, the top one is a shift up one. Whenever you add a number at the end, it goes up. If you add a number inside, it goes left. So one is a shift up, one is a shift left. Okay. Any questions on that? So let's try, we don't have to do this both ways. Let's do, let's just do the second one. You could do the first one, but let's do the second one. So f of g of x. So let's find it first, and then we'll do the domain. Can anyone tell me how I do this? How do I find f of g of x? Yeah.
Plug G into F.
Plug g into f. Perfect. Plug g into f. So I get square root of x squared. We kind of did one like this earlier, -1. And that does simplify. What can I simplify there? Yep, go on.
The square root of the square.
Square root.
X.
The square becomes x, and there's your answer. Now, the domain. 2 steps. Let's check the inside function first. Inside function was g of x. If I scroll up, are there any values in g of x I'm not allowed to use? Yep, my
Negative.
negatives. So can you tell me the values I am allowed to use?
0 and upward.
0 and up. So let's keep that in mind. So far, we're limited to 0 and up. Let's look at the second step. Examine the final composed function. X minus 1. Is there any number that you cannot subtract 1 from? What do you think, Emma? No. So there are no additional numbers we can't use from looking at the final one. So the only restriction is what Michael said from the original inside function. 0 and up. And if you graph this on your calculator, it can show you the right answer if you do it right. If you put it in like that, that's not showing you the right answer. It should only be showing me 0 and up. The calculator doesn't know that you had a square root and a square and cancel them. How would it know that? Well, you told it was x. But if you type it in like this, the square root of x squared, and now let the calculator figure out that it cancels out. Now, it graphs it correctly. It only graphs it from 0 and up. Okay. Any question on it? Okay, so I'm not going to do it the other way. We did f of g. We don't need to do g of f because we'll practice another one when we do the range. Range is a little trickier. Domain, I can be very specific. I can give you an exact set of steps. Do this, do that, you're good. You got the range. Well, our domain. With range, I can't quite do that. Range, it's basically, once you know the domain, you just have to ask yourself the question, okay, if I plug in the values that I just said I'm allowed to plug in, what kind of answers do I get? And what kind of answers you get, it totally depends on the problem. It's not like I can say you're always going to get these answers or those answers. It kind of depends. So that's where the calculator can kind of help you. You can look at how high and low the graph goes. If domain is left and right, range is up and down. It's the y values. Okay, so I've got it written here both ways again. I'll let somebody pick which way. We'll do it one way. So we have the option of g of f and f of g. How about Madison? Which way do you want to try to do it? G of f. So we're just going to do the first one. All right. So we're plugging f into g. Plug f into g. Okay, so let's just write that out and see what we get. So how about Alec? Can you tell me what I would get when I write that up?
You would just get the square root of x minus 3, right?
Should the minus 3 be under the root or outside?
Outside.
Outside. So if we think about yesterday, this is actually a shift of the square root function down 3. That's what it is. And I'm going to make a table, I said, at the end to show you that idea. So there's our function. Let's start with the domain. Okay. Check the inside first. Let's go up and look at f of x. Okay. Is there any restrictions on f of x? Yep.
You can't do negative.
Can't do negatives, so that leaves me with 0 and up. So from the inside function, I'm already limited to 0 and up. Keep that in mind. How about the final answer? Are there any restrictions you have to be careful about with what's in that box? Yeah, Connor, what are they?
It's 0.
0 and
0 and up, right?
0 and up. So it's actually the same restriction twice. You can't use negatives here. You can't use negatives here. So you stick to 0 and up with the inside function, 0 and up with the final answer. So the domain is 0 and up. Okay, let's look at the range. So nothing funny canceled out like a square root and a square, so we should be okay with that. Let's just type it in. Square root of x minus 3. So I told you this is a square root function, shifted down 3. Okay, well, we've got it here. What is the lowest value that it looks like it hits going up and down? Yeah.
-3.
-3. Okay, it hits -3, right? Right there. What is the x value when you hit -3? 0. Try plugging in 0 for x, you'll get -3 for y. Now the question is, how high up does it go? Does it ever level off? So to check that, we can press second table, and let's check some x values that go further and further away and see what happens. Let's check 10. Well, at 10 we're just above 0. That's still on the screen. Let's check 100. So now I'm going way to the right, and I'm seeing what happens to the y value. Okay, focusing on these numbers. So now it'll be up at 7. Let's go to 500. I'm at almost 20. Okay, if we go to 5,000, I'm at 67. If we go to 10,000, we're up at 97. Does it look like it's leveling off?
No.
No. It's not going up fast. You've got to go all the way to 10,000 on the x-axis before you get to 97 on the y. But it's never going to stop going up. So the range is all numbers from -3, and it will slowly keep going up. That's your range. Okay, I think the table is easier to use there because then you don't actually have to graph on the window. You can just keep typing in numbers all day and just see what happens. Yep. Yep. All right, so now I want to talk about the transformations. So yesterday we did a reflection over the x-axis. And what did you have to do to reflect something? What symbol did you have to put in? Yeah.
Change it to a negative.
Yeah, you had to put in a negative. And where we put the negative was basically in front. Okay, we put a negative in front. Well, let's try putting a negative inside and see what happens. All right? So I'm not going to stick a negative in front of the parentheses. I already know what that would do. It would flip it over the x-axis. Let's change x to -x and graph it. Let's see what happens. So I want to put the original in so you can compare it to something. The original will be in blue, and the one I'm looking at is going to be in red. Okay, let's see what happens. There's the original. And there's the one in red. How do those two graphs relate to each other? How would you describe, if you had the blue one, how would you describe to get the red one? Yeah, Sam?
It's would it be reflected over the y-axis?
Yeah, this is reflected over the y-axis versus reflecting over the x-axis. So we can see from what we just did we caused a reflection over the y-axis. So I don't think we looked at reflecting over the y-axis yesterday, and that was because if you have a parabola at the origin and you reflect it over the y-axis, you can't tell the difference. If you shift it like we did, then you can. All right, so we've examined all the transformations, but we specifically looked at them with y equals x squared, with parabolas. I just did it with parabolas because parabolas are something a little more complicated than a line, but they're not super hard. They're just like U-shapes. Well, it can be anything. So we're going to pretend now that we have any function. What's the formula going to be? F of x. F of x could be the square root of x, could be the square root of x plus 2, could be x cubed, could be anything. I'm going to use 3 letters in the formulas I'm about to show you. These 3 letters all represent positive real numbers. Okay, that's what that says. So the 3 letters you're about to see are all positive real numbers. Okay? That means fractions, decimals, it's okay, but they're positive. Okay, so on the left, I'll write down the name of what we're doing, and then on the right, what it actually looks like. So vertical stretch and shrink. We reviewed a problem from the homework. What operation do you have to use to stretch or compress a graph? Yeah?
Multiply x by a number.
Yeah, you multiply by a number in front of the function. So we talked about this versus that. If you multiply by a number in front, it will stretch the graph or compress it. Depends if it's bigger than 1, or did you multiply by a number less than 1. Okay, shifting up and down. How do we shift up or down? What operation do we use for that? About cat, do you remember? So it's not multiplication, because that was for stretching.
Is it when you add it onto the end?
Yeah, if you want to shift up, you add it onto the end. If you want to shift down, you subtract it. So you can take any function you can think of, okay? Even like functions we haven't studied yet. Something like this. If I take the sine of x, which is a function, and I take the sine of x plus 2, and I graph them, well, there's the original. Speed it up a little bit. And then the one with the plus 2 is the same thing up 2. So it works with any function. How about shifting left? How did we shift the parabola to the left yesterday? Yeah.
Plus a number.
That's when we do x plus a number inside the parentheses. And then to shift right, that's when we do x minus a number. Reflecting in the x-axis, we did that yesterday. That's when you put a negative in front of any function. Reflecting in the y-axis, that's new. I showed you that one just a minute ago. That's when you put a negative inside. Okay, so that summarizes all the transformations. So if you're going to make a reference sheet, that might be something to put on it. Might be helpful. Okay, any questions on those formulas? All right, so now what I'm going to do is I'm going to give you something, and I'm just going to ask you to transform it. But what's going to be a little tricky is I'm not going to give you a formula. I'm going to give you a picture. Okay? Just like an image. Let's look at that. There's your f of x. That's your graph. What's the formula for it? I have no idea. That shape is what you're working with. What I want you to do to that shape is the following. I'm asking you to do 3 things to it. The plus 1, the times 2, and the minus 3. Let's start with the plus 1. What is the plus 1 going to do to that graph? Yeah. It's going to shift it to the left. How many? 1. So I underlined it in red. You might not have different color pen, but I'm just trying to show you clearly. I'll do it in red. I'm shifting every dot left 1. If I do that, I get that. So that's the first thing. What about the 2? What does multiplying by a number in front do? Stretches it which way? Vertical. Stretches it vertically. So that means if you're going to stretch it vertically, does that change the x's or the y values? The y values. All the y values are going to get doubled. Let's start with this point at the top of the red shape. It has a y value of 2. If you double it, where is it going to be? 4. This has a y value of 0. Where is that one going to go? Stay right there. If you double 0, stay 0. And this also has a y value of 0, so it stays at 0. So after our vertical stretch, you now have something that looks like that. You've stretched it out. And now the last thing, the minus 3. What's the subtracting a number on the end of a function do? Come on.
Shift down 3.
Shifts everything down 3. 2, 3. 1, 2, 3. And 1, 2, 3. So if I didn't want to show all the steps in between, the final answer is just what's in blue. Okay, black was the original, and blue is the final answer. So there'll be a problem just like that in the homework. Any questions on that? Yeah.
Could you go back to the table?
Back to the table? Yep. The table. There we go. Okay, and that's it for section 1.6. So that finishes up chapter 1. Tomorrow we'll look at first section in chapter 2 and part of 2.2, but we definitely won't finish 2.2 tomorrow. Okay, and then that'll wrap up everything for this week. Okay, so homework tonight, it's on page 66. And it's 1 through 3, 6, 8, 13, 15, 32, 40, 44, 57, and 63. Okay, don't forget, I will be after school tomorrow if anybody needs to stay to make anything up or for extra help. If you have a test you need to make up, it's got to be done by Friday. And progress reports close on the 28th. So that's next shop Friday. So this is the last academic week before they close.